Okay, hello and welcome to our SIT program, Computer Engineering Intelligent Transportation. My name is Dr. Peter Waszecki and I will give you a short introduction, overview and a motivation of why, hopefully in the future, you should consider studying with SIT, specifically Computer Engineering Intelligent Transportation. So first and foremost, let us quickly look at what computer engineering is, what this program encompasses, and actually it is an interdisciplinary field which encompasses both traditional engineering fields and also modern mobility transportation related domains. So what are the traditional engineering domains which are covered within the computer engineering program? These are things like electrical engineering, computer science, and also telecommunication. On the other side, we have the modern components of this program, especially the mobility and transportation related domains like automotive technologies, smart mobility, and cyber-physical systems. So you might ask, why do we need such a specific mobility or transportation related program? And one of the reasons is that actually today's cars are much more than just means of transportation. They are basically computers on wheels. Most of the innovation in modern vehicles happens on the level of electronic systems, or so-called EE, electrical/electronic architectures, and cars are today basically interconnected, not just with other cars, but also with their environment, even with pedestrians. And just to give you an idea of what we are talking about when we say cars are computers on wheels, a modern vehicle today will have tens or even hundreds of so-called electronic control units, which are basically small computers interconnected with specific automotive buses and controlled by powerful automotive gateways. On the other side, where there is hardware, there also must be software, of course, and when we talk about software in cars, we are talking about millions or even hundreds of millions of lines of code and specific model-based system design, because it's not possible anymore to just have a few programmers develop this code. It must be a very elaborate model-based design process, especially because cars are safety-critical systems. And before I continue, I would like to show you a short video, which I like to call A Day in the Life of a Computer Engineer. So still, you might ask, why does this all matter for Singapore? Why does Singapore need such a specific transportation-related program? And you might remember a couple of years ago, the Prime Minister introduced a new initiative, the so-called Smart Nation Initiative, which goal was to transform Singapore through technology. And I quote the Prime Minister from 2014. He basically said that our vision is for Singapore to be a smart nation, a nation where people live meaningful and fulfilled lives enabled seamlessly by technology, offering exciting opportunities for all. So the initiatives, they encompass multiple fields, and as you can see here, one of the 6 main fields is transportation. So what are the key components of a smart nation with respect to transportation? Of course, first and foremost, we have the autonomous vehicles, right? That's the first thing everyone thinks about when we talk about modern mobility, innovation in transportation. And of course, this is an important aspect which we also cover deeply in our computer engineering intelligent transportation program. However, aside from the autonomous or self-driving cars themselves, we might also want to think about generally a shift of the transportation or mobility behavior in the population. For instance, maybe in the future there is no need anymore for so many privately owned cars, right? Maybe we want to reduce the number of cars and increase the public transport system, which would also encompass some self-driving buses or, like in this example here, on-demand shuttles. Right? So all big goals, but also on a smaller level, things that are part of this Smart Nation initiatives are, for instance, even the contactless fare payment, which to some extent is already introduced in Singapore. Also, this is a component of the Smart Nation initiative. And finally, of course, we need the more abstract and science and research-related components like data analytics for urban transportation or the different standards of self-driving vehicles. One more example I would like to give you from Singapore is the Smart Mobility 2030. It is a strategic plan developed by LTA, the Land Transport Authority, and Intelligent Transport Society Singapore, the ITSS. And what Smart Mobility 2030 is basically, it describes a smart urban mobility of the future where people and transportation systems are seamlessly connected, interacting through innovative state-of-the-art ITS technologies, ITS standing for Intelligent Transportation Systems. And the Smart Mobility 2030 can be divided into 4 big pillars. So the new systems, the innovations should be informative, they should be interactive, assistive, and of course also consider green mobility. Right, in times of climate change, global warming, this is also a very relevant and important topic. So how do we cover these pillars here in our computer engineering program? For instance, the informative pillar would be covered by our computer science modules. Interactive through telecommunication modules, and the rest, of course, through all the remaining engineering modules, which hopefully will equip our students then with the necessary innovative engineering solution capabilities. So you can see that this broad range of initiatives just in Singapore already indicates a growing industry and hence a rising demand for future talent. However, you might still say, okay, very nice to have such a focus on transportation, but what if some students decide that they actually want to go a slightly different direction, not specifically car or vehicle related? And the thing is that actually with the combination of electrical engineering and computer science, the computer engineering program prepares our students for many more emerging fields or industries than just the transportation domain. For instance, things like smart homes, right, where we introduce more and more technology in our everyday lives, in our homes. This is a big topic. Then, of course, the entire industry-related domains like smart grids, the intelligent transportation of power, Industry 4.0, which encompasses topics like automation, robotics, and so on. Then we have, of course, the big buzzword from the past years, Internet of Things, right, which basically describes the connection of all of our small electronic devices with one another, and basically also all the possibilities and opportunities which these changes bring in our everyday life. One big topic which I didn't cover yet is, of course, healthcare technologies. In our aging society today, this becomes more and more important, and also here, technology, electronics, computer science, engineering is so deeply implemented in those technologies that definitely it is also to some extent covered within the computer engineering program. And lastly, just to fill the gap, I want to mention information technology, because many of these domains here, which I was talking about, Internet of Things, smart homes or so, they are very dynamic, right? They might change. Maybe in 10 years from now, we'll have new trends. However, the information technology as a whole, which basically started with the advent of the internet 30, 40 years ago, this will not change so soon. So we can be pretty sure that even in 10, 20, 30 years from now, information technology will still be relevant. So after this motivation to why we have the computer engineering intelligent transportation program, let me give you a short overview. So again, I want to point out the distinctiveness of this program. It's basically a first of its kind in Singapore with such a specific focus on intelligent transportation. It's an interdisciplinary field with elements of electrical engineering and computer science. And for now, in the past years, we basically had an intake of 60 students per year, so you might regard it as quite exclusive, which of course has also many advantages. We can concentrate on our students maybe more individually. The program itself is heavily industry-driven. We have an endorsement of LTA, the Land Transport Authority Singapore, ST Electronics, Continental Automotive, and ITSS, the Intelligent Transport Society Singapore, and we are also supported by an industry advisory committee which is composed of members of the relevant industry. And I would like to present you just a few milestones from the past year, so you can see that we launched the program basically not so long ago in September 2016, so a little bit more than 4 years ago. Initially it was called Telematics, Intelligent Transportation Systems. Then we decided to change the name actually to Computer Engineering, because we feel that it much more describes actually the breadth of what we are teaching and the knowledge we are delivering to our students. So 2 years after the launch of the program, we had our first batch of students being sent out to the IWSP, the Integrated Work Study Program, basically an 8 months full-time internship with relevant industries. Also, some of the second batch students were sent out for industry induction. And finally, in October 2019, our pioneer cohort graduated and made us very proud and actually also showed that our idea with such a specific program worked. The program structure is basically a 3-year Bachelor of Engineering with honors, with 6 theoretical and 2 practical trimesters. So that's how it looks like. You can see in the 3 columns are the 3 years of the study, and the rows represent the different trimester per year. And as you would expect, the first year is dedicated to teaching the students the foundations of the program. In the second year, we have a deeper look into core modules, and then finally in year 3 we have specialization modules. You can also see that already in the first year, even so the third trimester is a break trimester. If students wish, though, they can choose to go out to industry already for 3 to 4 months for a industry induction, a short internship basically, but then in the second and third year we have our big IWSP integrated work study program where our students are spending 8 months full-time with the relevant industry. And in year 3 you can also see that DP stands for design project, which is basically a final year project, individual project where our students should demonstrate their abilities, what they have learned throughout the 3 years in form of a prototype, setup or project. In the brackets, if you wonder, those numbers represent the credit units for each trimester, so the sum over all modules of this particular trimester. So let us just very briefly take a slightly deeper look. I won't go through all of the modules, of course, which we cover, but just to give you an idea what we are talking about when we say foundation modules and core modules and specialization modules. So you can see here in year 1, the foundation modules are, of course, things like engineering, mathematics, Newtonian mechanics, electronic circuits, introduction to programming and object-oriented programming on the computer science side, linear signals and systems. So something you would expect also from a more traditional computer engineering program. But then already in the second year you can see aside from more traditional core modules like embedded system design, sensors and control, we have already modules like, for instance, operating systems and automotive OS, wireless communication, internet programming. So this already hints at the specialization modules in year 3, where we really target very specific transport and mobility-related modules like traffic regulation, traffic signals, automotive electronics, infotainment technologies, car interconnects, and vehicular networks. So all the necessary specialization related modules towards intelligent transportation. What you can also see here is, as I already briefly mentioned, in year 1, the third trimester, which can be used by our students for possible industry induction or a short industry collaboration, 3 to 4 months, and then the integrated work study program in the third trimester of year 2 and first trimester of year 3. Aside from this, also the design project, which I briefly mentioned before, the basically final year project, students may choose to still collaborate with industry on their individual project, which actually brings us to a potential up to 5 trimesters of student industry collaboration. And let me briefly give you an example how students might choose a strategy to basically stay connected with one particular industry. Here, for instance, they might start their industry journey with an industry induction in year 1, already 3 to 4 months, then stay with the same company during their IWSP in year 2 and year 3, and then decide to continue with their design project, still being supported by the same industry. So basically, out of 36 months of studying, 20 months the student had a form of student-industry collaboration, so more than half of the time. So why are we doing this? Of course, to create a proximity between the students and the relevant industry. Students become more grounded in the industry community, but also for the industry itself, it has lots of benefits to get the opportunity to early identify their future talent, basically, and it creates stronger bonds between students and company colleagues, and of course builds loyalty. So finally the students become hopefully technical practitioners with industry know-how on the one hand side and strong, relevant academic knowledge. So let me just give you some concrete examples of industries where our students can do their IWSP and then finally end up working at. So our first batch of IWSP companies were, as you can see here, some big players like Continental, Siemens, Infineon, ST Engineering, even government agencies like LTA. We also have PSA and some medium and small enterprises or companies like Init, Movita, Sync Pilot. So really, students can find industries which reflect also their own interest. This pot of companies, as you can see, grew with the subsequent years of or new batches of students with SMRT, NCS, M1, and many, many more, as you can see here. And just to give you an idea from our first batch of students, our pioneer cohort, most of them very soon after graduating found a job in one of those companies, as you can see here. So definitely not a bad start into their working life as engineers. So I was talking now a lot about student-industry collaboration, about the industries themselves. So what about SIT? What can we offer our students aside from the knowledge and the academic components? So basically, we also have our own applied research projects, which can be used for both industry collaboration on the one hand side, but also the curriculum. And just to give you two examples from our computer engineering program, we have a fully functioning autonomous vehicle, a self-driving car, basically, which we are using to demonstrate for particular modules of the program to show students how the development of such self-driving cars works, how the operation of such self-driving cars works, what are the risks, what are the opportunities. And another example are the smart lampposts, which we have installed recently at the Dover campus of SIT, which serve to demonstrate the communication abilities between cars and the infrastructure. So just to continue on this hands-on components of SIT and our computer engineering program, I want to show you some pictures of our computer engineering labs. We have a specific dedicated embedded systems lab where we teach modules like embedded system design, sensors and actuators, control systems, instrumentations, and displays. We also have fully equipped RF electronics lab, RF standing for a radio frequency for all the heavy wireless communication related modules and electronics related modules. And we even have a very specific specialized transportation systems lab with a huge screen on the wall where we can display transportation graphs and maps to teach transportation systems, transportation management related modules. And one last example, aside from our on-campus teaching, we also have many field trips to mobility and transportation relevant companies. And what we are planning for early next year, for example, here is a field trip to the Gardens by the Bay, which currently uses a self-driving vehicle operated by the company Wheelers, where we hope to also demonstrate to our students how does it work to operate a self-driving vehicle in Singapore. Then one topic I also want to mention, that aside from our academic components, industry components in SIT, we also give the students the opportunity and the support to participate in competitions. And indeed, in the past years, we had many of our computer engineering students participating in such competitions. For instance, here in 2018, the WorldSkills Singapore or the Smart Bus Challenge. We also had some students winning the Best Ideathon Award of the 16th ITSAP Forum in Fukuoka in 2018 here. Another example of the Smart Bus Challenge where our students also won the Commendation Award. So if students are interested, want to go slightly beyond just the academic and curriculum-related parts of the program, they of course can, and they have our fullest support. And finally, of course, aside from all the difficult studying and working, we also want to offer our students, again, perspective beyond the study life with our overseas exposure program. Once within the 3 years, selected number of students will go overseas. In the past years, we sent them to Chengdu in China, where they visited transportation-related companies, where they basically could learn about the different working culture and generally experience new environment, new culture, and hopefully also have a lot of fun. So with this, I would like to end my presentation. Hopefully, I could ignite the interest for computer engineering in some of you. And here you can see a picture of our pioneer cohort, which graduated in 2019. So maybe some of you will be the next. Thank you very much.
Hi everyone, I'm Joseph, a graduate student from SIT Telematics, and today I will be sharing with you my learning experience throughout the past 3 years. So this will be the scope that I'll be sharing with you on my learning experience, my IWSP experience as well as life in SIT. So what is IWSP? I'll share with you further on later. So before I delve into my learning experience, just a sharing of a bit of my background. I was from business course in Nanyang Poly, and then I decided to switch to engineering. Though it was challenging, I think it was still quite a fun and fulfilling journey for me. So SIT is about applied learning and practicality. Why so? That's because they want to prepare you to be industry relevant when we graduate from this program. So moving on to how do SIT prepare us to be industry relevant? Other than studying the theory part and the calculations of all the things that we are going to learn throughout, it's also about how we apply these theories into our projects. So one of the projects that I've taken up with my peers was that during year 1, we did a bus passenger counter project in collaboration with LTA Challenge. So what you have seen now is just showing the timings. But what we wanted to know is more of number of seats that are actually available on the bus itself. But more in depth into that, right? We want to break down even furthermore to the different demographics, such as elderlies, as well as whether is it wheelchair accessible. Yeah. So other than other than telematics being just focusing on transportation, right? We wanted to explore into more of different kind of industry, such as the agriculture industry. So in year 2, right, we were required to design our own problem and then coming out with our own solution. So my team and I, right, what we did was a hydroponics project. So this project, right, was to calculate using sensors and embedded systems, right, and then we tried to make the system automatic rather than what it is now being manually operated. So what we did was place some light sensors and then program it in such a way such that it is able to read light intensity and then turn the plants that is on this pipe, right, towards where the sun position is, such that the plants all receive a full amount of sunlight throughout the entire day. Yeah. So before even like designing the hardware, right, you have to think about how to design the software as well as using online tools, right, to even design the prototype out, and then thereafter to code it such that the program works for the system. Other than conducting projects, right, we are also given the opportunity to travel overseas for the exposure program. So for my batch, right, we went to Chengdu, China. So I must say that throughout this 1 week, right, we actually learn a lot. And it's not just learning a lot about the industry, but as well as the country, how Chengdu has actually moving and developing into in terms of their technology. So if you are given opportunity to go, right, you should really take it up and go for it. Okay, so I'll share with you a bit where we visited and what did we do throughout for the past 1 week during this overseas exposure program. So we got to visit bus companies whereby they're actually developing autonomous bus for autonomous traveling. So we got to even take the bus and then experience the entire journey throughout. Other than that, right, we also went to universities to understand how overseas universities are actually also teaching on the telematics sector, right, with their students, and what are the training tools that they're actually using, such as simulators, as well as designing a prototype, right, such that even their trains are actually traveling autonomously. Then other than all these visits to industry-related programs, right, to these industry-related companies or even schools, we also get some R&R time whereby we get to do some sightseeing as well as some shopping. So it's not just about studying, it's also about having fun while on this program. Yeah. So other than the overseas exposure program, right, we also get to be exposed locally as well. We get to participate with the help of our professors. We also get to participate in competitions such as Maple Tree as well as a Young Inventors Award. Other than all these, on top of all these competitions, right, there are also hackathons that are actually going on whereby you have a chance to have a hands-on, and this actually expose you to meet professionals, to know what the industry really wants. And then, so if you have a chance to do it, I strongly encourage you to do so. So after talking about the theory part, the school learning part of experience, right, I'll bring you to IWSP. So what is IWSP? It's actually Integrated Work Study Program. So it is like an attachment, also known like an internship when you did in your poly days. Yeah. But it is not an internship, because the company, when they receive SIT students, they don't treat you like an intern. Instead, they actually treat you like a staff, a contract staff to them. So you actually get to hands-on with that. And for me, right, with my peers, we get to be attached to ATT Systems Group, whereby they are a system integrator company, and I was with the project management department. So for the project management, right, we actually work with industry partners such as LTA, Desta, to come up to solve the problems to solve the problems that they have put forth, and then working with other contractors and subcontractors, right, to do up the system, and then delivering our system to resolve our clients' requirement. So on the top right, you can actually, if you stay in Ang Mo Kio area, you can actually see this along just opposite Ang Mo Kio Hub. And this is actually a counter whereby to keep track of people who are traveling by foot or traveling by bicycle. This was done so that they can have a number of it. And then the below one, right, is actually a security project with military bases. And then throughout the 8 months of IWSP, right, after you are done, it's not just working for them, but it is also a platform for you to start to think of your design project for your capstone project in year 3. So what I did was to incorporate one of my projects into my capstone project, and I designed a car plate recognition into the security system such that it is fully automated. So other than just working, right, other experience is meeting new people in the industry, and then especially through cohesion events. And so that it's not just working hard, but also playing hard as well, and mingling and understanding what the industry is about. So after sharing all the experience, I'll talk a bit about the life in SIT. So we understand in university, many may feel that, oh, we must get good grades because that's what that's what is going to help us to get a job, to secure a job, etc. But I beg to differ. I think that it's also important to build life skills and also build leadership and take up leadership roles, such that so that it builds your confidence. And when you go for interviews, right, you're able to showcase this to them and showing that SIT students, right, is actually a whole package rather than just academic smart. So it's not just about the paper. So luckily for me, right, I was given an opportunity to serve as a secretary and then got to organize different events, not just for our own telematics cohort, but as well as a school-wide event. Yeah, so this actually helps to build my confidence as well as communication skills with people that are from other courses as well. So as I said, in SIT or rather in telematics program as well, right, we are not just about studying. It's also about having the fun while studying as well. So we do come up with like some celebrations such as Chinese New Year low pay celebration, and then we also invite industry partners, right, to come in and then share their experience with us so that we are being kept up to date of what the industry is about. So it is really a very fruitful journey and experience in SIT telematics itself. So with that, right, I strongly encourage you to come and apply for our course, as you will definitely learn something out of it. And for me, like being from ground zero and then taking away something, taking a chunk of knowledge from it, right, it's really a fruitful and learning journey for me. So I really look forward to your application. And with that, that's all. Bye.